Now, our speaker, Tatiana, short Tanya Kozanovic, and Eleni Gartsou. They're working for a university that's based in Greece, and they are members of the coordination team of BioPackMan. BioPackMan recently started, and it's part of the group of 5 different projects that have been funded under the same call. We will meet them all in the next months, but also we have an in-person event on the 1st of December. So if you're in Berlin on the 1st of December, get in touch with us, and Tanya will be there as well with Eleni and with the other 4 projects.
Thank you very much, and Stella, for this kind invitation. It's a really nice opportunity to get in touch with a broader audience, let's say, the experts in the field of biodegradable bio-based materials. So today we will present you BioPackMan. That what we discussed in the beginning. BioPackMan was called from biodegradable packaging management. Started like the acronym, but full title of the project is Biodegradable Packaging Materials, Advancing Circularity, Sustainability, and Eco-Innovation. So first, to introduce the coordination team, our project is coordinated by Professor Kostas Charitidis, that is director of one of the laboratories here at National Technical University of Athens. And our lab is our nanolab, what we call it, different materials-oriented research. So I am Tanya Kozanovic, a senior researcher and a part of the coordination team, as well as my colleague Eleni Gartsou. We are together also with our colleague Melpo Karamitru, coordinating together with Kostas this project in day-to-day management, supporting all activities, as well as involving in the technical parts as well. So the outline of today's presentation is a little bit more about the project, scope, consortium, specific objectives, our ambitions, what we have envisioned through the different innovation pillars, and also to explore the collaboration activities. So as already Chiara introduced, the BioPackMan is one of the core topic projects that are funded under the core topic Resilience 0135 biodegradable polymers for sustainable packaging materials. That is part of cluster 4, and it was in work program for 2024. This is innovation action, and the project will is started on the 1st of June, ending by the end of May 2029, having the 48 months of its implementation. And you can see also some details about the estimated project costs. That is more than 9.5 million euros, and the contribution of EC is around 8 million. So where we are targeting is to explore further the material design space by exploiting the biodegradable compounds in order to tailor specific solutions for the packaging, both in the flexible and rigid applications. So we are developing different type of polymers, their compounds, and different type of additives that we'll speak later on. We integrate inside biodegradability as materials property, so to integrating it from its design to match disposal environments, take in mind, and also having both scenarios taking in care the regional disposal. Also, we are covering the full value chain. Our consortium is composed from the producers to end users, and we are focusing on different to create circular, safe, and societal by design approaches inside. Some words about our consortium. You can see here that some of the partners are already members of European Bioplastics. We have 5 universities starting from Greece that we are coordinating at National Technical University of Athens, but also Aristotle University of Thessaloniki. Then we have from Czech Republic, Thomas Bati University, from Estonia, Tallinn University. and also NTNU from Norway. Then we have the 4 research centers. It's happened that are all from Spain, EMPLAS, ITEN, ITA, and AMEN. SMEs that are from EXUS-IA Labs. Then we have the Bioplastic and large enterprises like Futero, the Next Innovation Hub, BioMe, Iotis, Hatzopoulos from Greece, and as well Novamont, Bolton, Manitoba from Italy, and Logoplast for Portugal. So looking on objectives, where we are targeting. We are targeting to develop new biodegradable polymer and its blends, focusing on PHAs, PLAs, and PBS. Then the second one is to add in this portfolio and to develop sustainable additives for functional performance and tunable biodegradability. We are dealing here with optimizing different approaches for their extraction and functionality, and we are dealing with lignocellulosic plant-derived different additives that will provide antioxidant, antimicrobial, barrier, and other functionalities. This, in our approach, is integrated end-to-end digital toolset to accelerate the design and virtual screening of biodegradable compounds. And further on is to improve biodegradable high-performance packaging, to produce biodegradable high-performance packaging intermediates, to improve the process development and benchmarking versus fossil-based approaches. Of course, later on to demonstrate our biodegradable packaging materials in the same packaging applications with clear end-of-life scenarios. During all our developments, we are following in alignment with safe and sustainable by design framework, with integrating with environmental and societal assessment as well. And of course, the final one is to liaison and increase exploitation, involving different stakeholders, consumers, increasing consumer awareness for the new developed packaging and adoption of consumption habits, different studies on economical feasibility, circular business models of these new packaging solutions. So our project is very ambitious. So in the following slides, we present you the different approaches and visions that we have. The first of one is, as already you saw from our consortium, that we have large companies that are dealing with producing the same bio-based materials. So our focus is to develop the new PBS grades with different approaches through graphing and compounding to enhance thermal, mechanical, and rheological performance. The PLA grades and PLA PHAs blends to enhance the further on properties. And of course, the different new types of PHAs, mainly basing on the short chain length and medium chain length to tailor physical and thermal properties of the same polymers, but and later on their compounds. So these will be like our biopolymers matrices that will be assessed through the blending, but as well as compounding with different bio-based additives. So we have lignocellulosic additives that are lignin-based nanoparticles, cellulose nanofibers. We have different biodegradation modulators that will be involved. Then we have the extracts, also another extracts from the plants like pinosylvin, betanin, different polyphenolic and flavonoidic antioxidants for different food waste streams and biomass. And one approach is also given to urosamine and other amide waxes that will be more eco-friendly to be introduced also in the processing aids of our packaging solutions. The next ambition is the development of digital toolset for accelerated discovery and design to optimize our biodegradable polymer materials. One main focus is here to develop BioPackMan platform for virtual screening that will integrate all of these different approaches from accelerated discovery and design of biodegradable compounds, having inside machine learning polymer informatics pipeline, different tools that will integrate molecular dynamics, polymer fingerprints, and machine learning algorithms to help us to develop new biodegradable compounds. Then later on, this will be this will start from the beginning of the material developments, but also follow up to final packaging iterative designs. Also, this includes biodegradation and exotoxicity in silico prediction tools, where we'll apply different QC, different models that correlate molecular descriptors with biodegradation, exotoxicity, and physicochemical properties, as well as on the final, or let's say pre-final design of the packaging. We will work on their aging to predict shelf life and end-of-life disposal, as well as biodegradation data sets to provide, to train and validate predictive models. The next ambition is to develop biodegradable and sustainable packaging solution to demonstrate and validate them. So we are focusing on two main, let's say, types of packaging. One is the laminates and co-extruded films, and the second one is the rigid packaging, meaning bottles. So our focus is given on the novel tailor-made biodegradable and recyclable packaging structures that will provide new solution for the food applications, as well as home and care and personal care products. So you can see for the flexible packaging, we will have some pouches on confectionery products and also pouches for the some detergents and washing products. As well, these new materials that will be developed in the project will be validated for film casting, extrusion, lamination. And in case of rigid packaging, we are focusing in the case of the food application for syrups and the powders. And in the case of home product, and would be the cleaning products and the personal care shower gels, for example. So in this case, our new compounds will be validated for extrusion blow molding, injection molding, and stretch blow molding processes. So one of the big also ambition is to develop this environmental specific biodegradability testing and adopt systematic approach that will align with environmental and end-of-life scenarios, but following also safe and sustainable by design principles. So we have envisioned multi-tier testing for biodegradability, starting from material level, where we will firstly assess the new developed biopolymers, as well as additives and master batches, then adjust if needed by different biodegradability modulators. And then level we will test for the same biodegradable polymer materials in means of the compounds or intermediates for the packaging, together with adhesives that are also developed in the project, coatings and on laminates level. And the third level is on the same packaging prototypes, meaning on the pouches and bottles. So we'll have like first tier preliminary in silico and lab testing. The second is control environmental testing and mesocosmos tests. Of course, one of our ambition is to demonstrate recyclability of our materials and to develop the case-specific end-of-life assessment, as well as implement through, as already mentioned, through the whole development of materials, safe and sustainable by design principles. So we will explore in our project different sorting, mechanical, chemical, and enzymatic recycling technologies, targeting to increase efficiency and to assess properties and performance versus recycled content. target and achieved 30% of it. Of course, we are focusing on at least one mechanical, one chemical recycling strategy to be developed with 60 to 80% of process yield. And as well, we will test some of the reclaimed monomers or oligomers to feedstock to produce new type of PHAs and PLAs. One big part of the project is societal engagement to enhance acceptance and packaging products. So we have envisioned different collaborative awareness campaigns, skilling education programs, and policy recommendations. So, for example, a lot of different approaches. We have in consortium also expertise on societal and human sciences to develop methodology to increase the consumer awareness. We will work on and highlight a lot on the different disposal methods in order to highlight benefits for the biodegradable packaging materials for everyday use and circular end-of-life treatments. We are working also as part of the project on clear labeling on our new packaging in order to increase the consumer trust. And of course, one big part of the project is integration of eco-design for circular packaging, as well for the educational program. It's a vision different future education and learning dimensions to preserve European workforce industry-specific knowledge and to increase industrial and leadership and competitiveness. On footprint and increase knowledge on safety and environmental assessment of new biodegradable materials, and always protect human health and environment. And just mentioned below are several sustainable deal growth. So this would be on this part. Then in this slide, actually, we can summarize all our innovation pillars in the project. So you can see that starting with the first pillar is dealing with this virtual screening for accelerated discovery and design of biodegradable compounds. And then this is connected actually with all pillars and giving feedback both for the innovative and sustainable material solutions that in dealing with the development of all different biopolymers and their compatibilization strategies. And then also we have the pillar 2 that is dealing with, this is pillar 2 that is also including development of sustainable additives. It's cellulose nanofibers, different extracts from the plants. Of course, we have to protect these different type of materials, of biomolecules. So we are approaching different modification strategies, including nanoclays, carbonates, and silicates to provide them in the form that both will protect them and also to make compatible with the polymer matrices. Then we have the third pillar that is dealing with innovative packaging and processing, and where we have all of these different phases of testing and compounding of materials, upscaling to intermediates, and finally to packaging, as well as following it throughout the different process optimization in industry, industrial partners that will produce the packaging. And the fourth pillar that is dealing with all sustainability, end-of-life solutions, and environmental biodegradability. So there all approaches presented before dealing with mechanical and chemical recycling, biodegradability pathways, including this multi-tier testing and validation, and labeling requirements will be assessed. And the final pillar is holistic sustainability assessment, integrating SSbD design, LCA, LCC, societal LCA, techno-economic analysis. We also dealing with pre-normative assessment, policy recommendations, and already presented the awareness campaigns and upskilling. So what we have also envisioned with our project is to collaborate with both sister projects, but also the expertise in the field. So we have envisioned a formation of advisory board for biodegradable packaging. So we have already invited the coordinator of sister projects, BIAP, Greco, IOL, and Upcycle. And also we'll make some connections with some other relevant ongoing European projects, either innovation test beds or CBE projects, are either cluster 4 and 6 projects, as well as association as we are today with European bioplastics. So if anyone also of you would be interested to join our advisory board, are more than welcome to discuss with you more of this. So you can see also that we have envisioned some annual meetings in this content to consult and to advise on the mainly on EU legislation and compliance, support dissemination via different networks, and to contribute to stakeholder engagement, and promote, of course, this development of bio-based and biodegradable materials to be used in application-based packaging. Some of ideas with in collaboration with our sister projects in the European bioplastics is already present, having events like today's to join awareness outreach campaigns, or in the 1st of December, this will be actually done in Berlin, and share some experience and findings in our project to align and to make larger impact from our projects.